All right, so today we're going to be taking a look at a lesson on factors, multiples, and prime factorization. We're going to cover all of them. Some of the stuff is review from previous grades. Some of the stuff is a little bit new, and we're going to try to go through a couple of different ways of solving these problems, or at least looking at the problems as we go. This lesson is part 1 of 3 of a bit of a bigger grouping of lessons dealing with prime factorization, lowest common multiple, and greatest common factor. So I want to start off just by looking at what are multiples. If you think of a multiple, you can kind of try to think back to work that you've done in the past, and a multiple being a number which is kind of going forward from any value. So I'll use an example here of 6. So we'll give the first 6 multiples of 6. Well, the first one is 6. So 6 times 1 is 6. The next one will be 6 times 2, which will be 12. And then 6 times 3, which is 18. And then 24. And then 30. And then 36. And then on and on and on and on and on. There is an infinite number of multiples for any value. In this case, the value of 6 has an infinite number of multiples. They just keep going up. We're just going to keep adding 6 each time, or it's a multiple. 6 times something, multiplied by something. So a multiple is a number that can be divided by another number, okay, without a remainder. So 36 divided by 6, right? We're looking at that specific value. So 36 is a multiple of 6. Next step, let's think of factors. So now we're going to think of factors of 36. Multiples are getting bigger. You are multiplying by something to get bigger. A factor is a number which divides evenly into 36. Or evenly into whatever value you have. Now, to think of those values, we can think of numbers which multiply to get 36. Something like 1 and 36. Those are going to both be factors of 36. The next grouping, well, does 2 work? Yeah, we could do 2 and 18. So those are also factors of 36. They both divide evenly into 36. Then we have 3 and 12, and we have 4 and 9, and finally we have 6 and 6, which because they're the same number, we're just going to leave as 6. There are a finite, not infinite, a finite number of factors of any number. Some numbers are going to have only 2 factors. Okay, we call those prime numbers. We'll get into those in a little bit. Some numbers are going to have a lot of factors. Okay, 36 is maybe somewhere in between. But again, we can just go through piece by piece and try to figure out what are the factors. So in summary here, a factor is a number or algebraic expression that divides another number or an expression evenly. In other words, no remainder. So all of those numbers there, 1, 2, 3, 4, 6, 9, 12, 18, and 36, you can divide evenly into 36. Okay, so those are all going to be factors of 36. The next thing that we're going to go over, and this is something that you've probably seen before or might have seen before, is something that are prime numbers. Prime numbers are values that are greater than 1 and that are only divisible by 1 and themselves. So we can only divide them by 1 and themselves. Now, 1 is not a value. It has to be bigger than 1. Okay, but let's think of some examples. So the smallest example that we have is the number 2. Okay, the only values that you can divide evenly into 2 are 1 and 2. That's it. So it's a prime number. Now, the interesting thing about 2 is that all other even numbers are divisible by 2. So 2 is the only even number that is a prime number. So let's think next. Is 3 a prime number? It is. It's only divisible by 1 and 3. 4 is even, so it's not. 5 is. Yep. It's only divisible by 1 and 5. 6, even. Let's quit doing the evens. None of them are going to be prime. So 7, yep. 9, no, it's divisible by 3. 11, yep. 13, yep. 15, nope, divisible by 3 and 5. 17, yep. 19, yep, and on we go. So we have 19, 23, 29, 31, and 37. So these are all going to be prime numbers, and there are way more prime numbers as well that come out from these that keep on going. So there's a lot of different prime numbers that we have. For the most part, we're going to deal with smaller ones. You can think of like 2, 3, 5, 7, 11, 13 maybe. Maybe we'll throw some of the bigger ones in there at times. But for the most part, when we talk about primes, we're only going to deal with the smaller ones, at least the values that I'm going to give you. So let's look at something that we can do with prime numbers. We can factor a number using a method called prime factorization, and that is factoring a natural number into a series of prime numbers. The product of these prime factors will give the natural number, and we can use, and then we'll look at some more stuff that we can do with it later on. So let's prime factor the number 132. So this is going to be a little bit new. We're going to look at the process, and then we're going to look at some of the values of this process in our next lesson after this here. So let's prime factor 132. I'm going to give you a method of doing it, and then I will have another video available that you can look at, which gives you another method to do it. If you want to look at that, you gladly can as well. So to prime factor 132, I'm going to recommend that you put it on your calculator as 132, and we're going to start dividing by prime numbers, which will hopefully work, and we can try to get it as smaller and smaller and figure out what our prime numbers are. So if you have a calculator, grab it, pull it out. Let's try this. Let's try doing this together. And if you need to pause the video to get your calculators, we can do that as well. So 132. Now, is it divisible by, what's our smallest prime again? 2. All right, let's start with 2. Is it divisible by 2? Yeah, it is. This is an even number, so it's divisible by 2. So try it. What is 132 divided by 2? It's 66. So what I'm going to do here is I'm going to write down 2 as being a prime factor because it works. And then I'm going to put 66 on top because that was what I got as the answer from that. So once we've done that, now we're going to ignore the 132 and we're going to stick to 66. So keep the 66 in your calculator. Let's try another number. Can we divide it by 2 again? Yeah, it's still even, so we can divide it by 2 again. And we're left with 33. Now we're going to keep on going. Can we divide it by 2 again? Nope, we cannot because it is a odd number, so we cannot divide it by 2. So now let's move up into some of our odd prime numbers. Can we divide it by 3? Yep, try it. 33 divided by 3 is 11. Yeah, so 3 is another prime factor of 132. Now we're left with 11. What can we divide 11 by? Is it divisible by 2? Nope, and we're done with 2's already. 3? Nope. 5? Nope. 7? Nope. 11? Oh, yeah. Yeah, we can divide it by 11. Okay, 11 is a prime number. So once we get to one of these, we're going to put that in as the last one, and we're left with 1, and that's where we're going to stop. Okay, we're not going to go any farther. This tells us that we can make a prime or product of primes, product being multiplying, of these 4 numbers, and that'll give us 132. So 132 looks like this: 2 times 2 times 3 times 11. Okay, it is a product of prime numbers. 2 times 2 times 3 times 11. We can simplify this a little bit, and we'll look at why we do this a little bit later, but we can make that into 2 squared, and that way then we have all of our 2's put together and we know how many of them we have. Now, if we look at the number 132 and we break it into factors, it's going to look like this. The factors of 132 are 1, 2, 3, 4, 6, 11, 12, 22, 33, 44, 66, and 132. Every one of these factors, other than 1, can be made with a combination of prime factors. Pick any combination. 2 times 2, it's 4, it's on there. 2 times 3, 6, it's on there. 2 times 2 times 3 is 12, it's on there. 3 times 11, 33, it's on there. 2 times 11, 22, it's on there. 2 times 2 times 11, 44, that's on there. Okay, all these numbers are on there and it gives those values. Okay, so we can find the factors once we know our prime factors. So it's something that we can think about as we're working through these types of questions. So let's look at a couple of examples, and I'll get you to kind of work on these. Pause the video as you're going, try to solve at least 1 or 2, and then come back and we'll see if we have the answer. So the first question here is give the first 6 multiples of each number, and go. All right, let's try it here. The number 8. Well, we have 8, 16, 24, 32, 40, and 48. 14, 14, 28, 42, 56, 70, and 84. And finally 21, 21, 42, 63, 84, 105, and 126. These are our first 6 multiples. All you're doing, you're just going up by the number each time. Okay, so 8, 16, 24, 32, 40, and 48, you're going up by 8 each time. All right, let's go one more step here. Let's find the factors of each of these numbers. Okay, pause the video, try it, see if you can get all the factors. Some might be a bit more difficult than others, and then come back and continue. So the number 24 has factors 1, 2, 3, 4, 6, 8, 12, and 24. Did you get them all? Good job, way to go. Okay, I'm guessing you got them all, right? Okay, make sure that we're getting all of them, and you can again do them in pairs, 1 and 24, 2 and 12, 3 and 8, and 4 and 6. 132 is a little bit more difficult. It's got a few more factors, but these are the factors of 132, which is the example that we just did on the prime factorization side. And 196, again, is a bigger number, but actually has less factors. It's 1, 2, 4, 7, 14, 28, 49, 98, and 196 as the final. Okay, now let's do some examples where we have to prime factor certain numbers. I'd like you to try prime factoring the number 104. Okay, I'll give you a second, and then come back when you're ready. All right, 104. Okay, now it's going to be divisible by 2 because it's an even number, and we're going to get to the point where we get 2 times 2 times 2 times 13. Okay, that 13 is a prime number. Yeah, it's a little bigger one, but we could still potentially see that. So our prime fact, or our product of primes, is 2 times 2 times 2 times 3, or times 13. The prime factors of 104 are 2 and 13, and we can describe that when we put them into exponents, where 104 is the product 2 cubed times 13. Okay, so 2 cubed times 13 would be our product when we have powers in there. All right, give this one a shot. 630. Can you prime factor it? Give it a shot, pause the video, and then come back and we'll try it. Welcome back. Did you get 2 times 3 times 3 times 5 times 7? Yeah, a bunch of different ones. We have 2, 3, 5, and 7. So we have 4 different prime factors. And if we put them into our product of product using powers, we're going to have 3 squared in there, and everything else just has a single one. Let's do another example. Try this one. 2,772. And go. Okay, welcome back, and let's us try here. Did you get 2 times 2 times 3 times 3 times 7 times 11? Okay, 5 is not in there this time. There's no 5s. But we also have the 5 and the 11 as well. We can combine the 2s and 3s there, so we have 2 squared and 3 squared, and that just makes it a little bit simpler as we put this together. All right, let's do one more. 3,300. Pause the video, and then come back once you get it. All right, 3,300, it's a much bigger number. So again, we can keep dividing by prime numbers. Start small, start with 2, then move up to 3, then 5, then 7, then 11, then 13, until of course you get to the end, and that might be later on. But you should have something that looks like this: 2 2s, a 3, 2 5s, and an 11, and that would be just in a simplified version. I hope that worked for you. I hope you were able to get a hang of that. You will be doing some practice with that. If you have questions, feel free to ask, either email or put a message in the comments, and I will do my best to try to answer those as much as possible. I will also have another video posted that has another method of solving, and I use 3,300 as my example for that video as well.